Hello everyone, it's Drew here again, and today we're going to be talking about data structures in Python. So what data structures are is they allow us to use a collection of related data and allow them to store them in one place together. So with data structures, there's going to be four main ones that we're going to be talking about today. There's going to be lists, there's going to be dictionaries, sets, and tuples, or tuples depending on what you want to call them. And with each of these data structures, there are three attributes that go along with them. And those three attributes are whether they're ordered or unordered, changeable or unchangeable, and if they allow duplicates or they do not allow duplicates. So I'm going to go through each of the different data structures, show you some examples, and at the very end I'm also going to show you a real life example of how you're going to be using data structures within the data field. So whether you're going for data analysis, data science, or machine learning, or beyond that, this is definitely something that could definitely help you out. And if not, if you're going for web development, definitely stick around, so it definitely gives you an idea of what you might use it for as well. So, because you never know, you might need to work with data, especially if you're going to go for backend as well. Okay, so yeah, without that being said, let's go ahead and start. So with ordered and unordered, that just essentially means that each position of that collection, of that list, or of that tuple, or whatever data structure it's in, that position does have its own index. So you'd be able to refer to that index. So it's okay. So in programming, things start at 0. So if I was in the first seat, I would be in seat 0. If I was in the second seat, I would be in seat 1. So if I wanted to grab that seat, I can refer to that index as seat 1 and grab that specific seat. So, and with unordered, things are not in order, so if you try to grab things by the way they're placed in that list, it will not work. With changeable and unchangeable, that's pretty straightforward. The collection can be changed, so if you wanted to change one of the elements in your collection, you will be allowed to do that. And unchangeable is just the opposite. Once you have like one example will be is a set. Once you have that set or that tuple, you will not be able to change it. So it will stay the way it is. Another one is duplicates and allow duplicates. That's another one. Can you have 2 or more of the same element in that collection? If it does, you can. If it does not, then you can't. Okay, so let's go ahead and get started with the first our first ones. So what we have here is lists. So with lists, this is a data structure that is ordered, changeable, and does allow duplicates. So to create a list, you're going to use these square brackets right here, and you can use all different sorts of data types within your list. So you see we have a string, we have an integer, we have a floating point number, and we have a Boolean. So you just wrap it with these square brackets, and I just called it list1 as a variable. And so you see Drew 27 2.5 and true. So you see we have our list that's printed out here. So the first attribute is that it's ordered. So if we wanted to access my name, we would just call the 0 element, and we get that first element right there. Also, let me zoom out just a little bit so I don't have to keep scrolling so much. Another thing is that they're changeable. So we have, the same list up here. So this second element, 0, 1, 2, that's this number right here, 2.5. If I wanted to change that to a 3, I will be able to do that. So now you see, instead of 2.5, you see now we have 3. And it does allow duplicates. So you can see we already have a 27 up here, but if I wanted to append or add another element that also has 27, I can just do dot append 27, and now I will have 2 elements with the same value. The second data structure we'll be working with, or we'll be looking at, is tuples. So with tuples, they are ordered, unchangeable, and they do allow duplicates. So to create a tuple, it's very similar to a list, but instead of using the square brackets, you're going to use parentheses. So to create a tuple, that's literally the only difference between that and a list. So the first attribute of a tuple is that they are ordered. So if you try to access the third element, and you just put a 2 here, you'll be able to access that third element and get 2.5. Second is that they're unchangeable. So let's say I want to change this value from 27 to 28. Well, it is not going to allow me to do that, because once tuples are assigned, once they are created, you cannot change them. Another thing is that they do allow duplicates. So I went ahead and made another tuple, and as you can see, we have two different values that are duplicated. We have 27 and hello, and you can see it printed out here. Third data structure we'll be looking at are sets. Now sets are unordered, unchangeable, and they do not allow duplicates. So to create a set, it's very similar to the previous two. With lists, you have the square brackets. With tuples, you have the parentheses. With sets, you use the curly brackets. So its first attribute of a set is that it's unordered. So with the other two, we were able to access that first element, but with this, we cannot access that first element because they are not in order. And you can even see up here when I printed this out, they didn't even print out in order, because obviously my name is first, and then my age, and then this number, then true, and then you see they're not even in order when they print it out. So, and then you see a type error here, set object does not support indexing, so it's unordered. Also, it is unchangeable. So if I wanted to, let's see, I got the first element there, which is technically the second element. So if I wanted to change this element 27, and I wanted to make it a 25, it will not allow me to do that either. Yep. So type error again, set object does not support item assignment. So we can't do any indexing, we can't change it at all, and also we are not allowed duplicates. So if I were to make this set right here, you can see it only prints out my name one time. So sets are very good if you really wanted a strict list, something that was unchangeable, and something to the point where if you didn't want any duplicates, it would only grab one of the elements. So you can see right here it only has Drew one time. So it's just depending on the problem that you're looking to solve, and then the more you program, the more you're going to get more, familiar with these data structures and when you're going to need to use them. So don't get tripped up by all the different types and knowing all the different details about them now. Just just practice with them every day, and the more you do it, the more you're going to get comfortable with it. So the last data structure we'll be looking at are dictionaries. Now dictionaries are unordered, they're changeable, and they do not allow duplicates. So just like with lists, we're going to use the curly brackets, but instead of just putting one element, separating it by a comma, one element, separating it by a comma, what we can do with dictionaries is use these things called key values, where the key is like the description of what our value is going to be. So you see this first key value element, our key is our name, and the value is, well, in this case it's my name, but when you do this, it would be your name, so it'd be the person's name. And then I separate it by a comma, and then we have our second key value, which is age, and then you got 27, and you see each of these key values is separated by a colon. So each key value is separated by a colon, And then you have all these key values here, and each of the key values, all four of these key values, are separated by commas. Okay, so it's just like up here, you know, like the setup, like the way it's the way you code it, but you're essentially just putting key values instead of just one word or one string or one element, one single sort of data type. Okay. And then, so that's all you do for that. And you're going to also see its the first attribute, how it does not return in order. So you can see the name, age, weight, programmer. Now it prints out age, name, programmer, weight. So it does not print out in order, just like some of the other ones. But if you did want to access this one of these elements, how you would access it is through the key. So if I wanted to access my name, I would just type in name and I put that in square brackets. So you see this profile Drew is my name, or is the variable to this dictionary. If I put in square brackets one of the keys, so and in this case I put weight, I hit Shift Enter, I'll be able to get that value. You'll see here that they are changeable, so now instead of 150.5, if I needed to change the weight to 160, I can now change that weight to 160, so they are changeable. And with duplicates, you will see that they do not allow duplicates. So you see that I have a key value name with somebody else's name, so name Drew and then name Alex. Because there's two keys that are the exact same, that is not allowed. So it's just picking one, and I actually don't really know how it ends up picking this one first, but it just that's essentially what it does. So if you have a bunch of elements in your dictionary that are all duplicated, only one of them is going to print out. Okay. So, and now I want to show you, now that we went through all the data structures, now I actually want to show you a real life example of how you might use these different data structures in a data analysis field. Okay. So I will include this file in the description below, but essentially this is a data set of student scores and all of their and their or not their score. It's this. One column is the amount of hours the students have studied, and the second column is their scores that they've gotten. I'm sorry, I don't know why I just got tripped up by that. But yeah, it's literally just it's a small data set of just two columns. One is the amount of hours studied, the other is the student scores. So all you got to do is import Panda as PDs. Make sure if you're in Google Colab, you go to Files, you go to Upload. And when you go to your local directory, you can just click on this file name, and it'll upload right to your Google Colab. So you save that into a variable, and I just called it file. And then use this PD is, remember, this PD is a placeholder, so you can call it anything you want to. But in order to put this file in a data frame, you just type in pd.readcsv parentheses, and then that is what puts this file into the data frame. So you just put this variable within the parentheses, and then just go ahead and print out your data frame. And you notice I put a dot head method, which will only print out the first 5 elements. So you see we have hours, we have scores. Now, so an example of something we might use for with data structures and data analysis is we might want to change up the column names. So so we have our scores, which is our data set. So this is the name of our data frame. If you wanted to change up the column names, you can just add the columns method right here. And then and then within a list, you can actually just type in your new columns. So if you do scores, which is our data frame, dot columns equals, and then just type in whatever you want to put in as the replacement for the columns, for the column names. And remember, they have to be 2 because there's 2 columns here. So you go ahead and print that out. And voila, you have your new column names. So here's an example where you can put it in a list. Now I'm going to show you an example of how you can add another row, another instance down here at the bottom. So you'll make, instead of 5 instances, you'll have 6. And you'll be doing that using a dictionary. So up here you see that I went ahead and I saved scores dot head to score. So I just saved, literally just saved these first 5 elements, so I don't have to keep typing dot head all the time. I could just save it like that. So I just went ahead and saved it as scores. So now I only have the first 5 elements as a data frame. And now what I'm going to be doing is appending another instance to the bottom of that data frame. So to do that, you do scores, which is your data frame, dot append parentheses, and then in that parentheses, you put in your dictionary. And with your dictionary, remember, use key values, okay? So your keys are going to be your column names, so study hours, so that's like that up here, study hours. And then your value is going to be that value, which is going to be down here. It's going to be that next instance. Same thing, you separate that by a comma. Test scores, which you have up here, so that's your key right there. And then your 76, that's going to be the value down here. And then one thing that you'll learn in data analysis is, like, a lot of times when you print out a data frame, like when you get another output, is you'll get another column that's added called the index. So it'll take this index and it'll just add another column to here, and it's very unnecessary, and you'll see when you try it out. But if you do ignore index true, you can just get rid of that. You can just get rid of that index column that's going to be added. Because it is unnecessary. Because otherwise, you're just going to have to drop the column, and that's just another step. So, yeah, if that didn't really make sense to you, don't get too tripped up by it. This was just focused on data structures. I just wanted to show you an example of that, but that's essentially what ignore index does. Because when you output another data frame, it's going to add another column here called index, which is going to have all these elements there, and that's unnecessary. And so if you just do that, it won't even include it. So if you hit Shift Enter, you now officially have your new data frame. So you see that we now have these elements down here. Yeah, you see how we have these new elements down here. So we have 9.9 under study hours, and we have 76 under test scores. So that was just a, I wanted to kind of run through the basics of data structures and also show you a real world example of how you might use this on one of your projects. So, I hope that wasn't too daunting. So I hope you guys have a good rest of the day, and definitely if you have any feedback, or if you definitely like this video, please like it. Definitely please subscribe. I'm always trying to connect with people and trying to build a community as much as I can. So I hope you guys have a good rest of the day, like I said. So yeah, see you in the next video. Bye bye.